Hi, welcome to this tutorial on simplifying expressions. Now, in an expression like this, you've got what we call three terms. You've got the 5x, you've got the 2x, and you've got the minus x. Three terms, and they're all the same kind of term. So you can actually simplify this. 5x and 2x is going to be 7x's. And then take away what is essentially 1x. We don't write a 1 here, okay? It's just understood that we're taking away 1x. So we've got 5x and 2x, which is 7x. Take away one more x is going to give us 6x. So we would write down here that this is identical to, and it's best if you can try and write 3 lines for the identical sign, and it turns out to be 6x. Okay, here's another one. Okay, number 2. Now I've picked this one because we've now got a lot more terms, and you'll notice that when we look at these terms, we've got what's called an xy term here, 6xy. We've got an x term here, minus 3x. We've got another xy term here, minus 8xy. And here we've just got a plain number, often referred to as a constant. So we've got a constant here, plus 4, and a final term, an x term, plus 5x. So if we're simplifying this, what we've got to do is find terms that are the same type and group them together. So here we've got an xy term and we've got an xy term here. So we can group these together. We've got 6xy's, take away 8xy, so that's going to be identical to minus 2xy's. Alright. What else have we got? We've got an x term here, minus 3x, and we've got an x term here, plus 5x. So we can group those two together. Minus 3x plus 5x is going to be plus 2x. So pop that on the end here, plus 2x. Now, what are we left with? We're just left with this constant term plus 4. There's no other constant terms in here, so we just put plus 4. So we end up simplifying this expression down to 3 terms. Now you could leave it like this, but really it's best to make sure that your expression, if possible, starts with a plus term. And I've got 2 plus terms here, plus 2x and plus 4. So what I could do is just write this as being identical to, and let's suppose we take this term first, 2x. I don't have to write the plus in front of it, it's understood to be a plus. So I've got 2x, and then I got the option of either writing minus 2xy or the plus 4. Let's suppose I choose to write minus 2xy in. There you go, minus 2xy and then plus 4. But I could write is identical to 2x plus 4 minus 2xy. It doesn't matter the order of the terms. Okay? Right, let's have a look at another example which I want to illustrate another point. Okay? Now, in this third example, you'll notice this time that I've gone for terms with powers in. This term here is an x squared y term. Okay? And we've got an xy squared term, an xy term, and a y squared x term, and a yx squared term. Now, I've also put in an extra in this example as well, because there are terms that are the same, but I've written them in a different way. Let's have a look. We've got an x squared y term here, and there is in fact another x squared y term in this expression. It's in fact this term down here, although I have written it back to front. It says yx squared, but this is the same as x squared y. So we have got 3x squared y, and we have got plus 5x squared y. So this is identical then to 8x squared y. And I could write that as yx squared if you like, but it's a good idea, good practice to try and write in alphabetical order. Okay, another thing that I would suggest you do, we're not finished with this question at the moment, but is to put ticks over your terms when you've collected them together, because sometimes you can miss terms. So for instance, we've done this one and we've grouped together it with that one. What else have we got? We've got an xy squared term here. Have we got any more xy squared terms? Well, yes, we have. We've got this one here, although I've just switched these around. But it's still an xy squared term. So we've got minus 2xy squared minus 7xy squared. So that is minus 9xy squared. So just put that in there. Put ticks over these two terms, saying that we've collected those together. And we've got one more term left over, an xy term. There aren't any more xy terms, so we just simply put plus 5xy. Okay? So that's that one there. So I've tried to show you different types of simplifying and the problems that you can get. Now, what I'm going to do now is just give you an exercise, okay? Just 3 more questions, just kind of summarizing what we've gone through. And I've also tried to pick these questions to illustrate some further points. But take a few moments, just pause the video and see if you can do these 3 questions, okay? Don't forget to put your identical sign out to the right here, okay? And copy them down, see if you can set them out properly, and pause the video, come back in a few moments and I'll run through these answers with you. Okay, well, let's see how you got on. Okay, well, the first one here, number 4, 8x minus x minus 1, I chose this one because 8x minus x, I'm just wondering, whether you made a common mistake. 8x take x, I often see students knocking off the x's and just writing this as 8. No, it's not, okay? It's not 8. 8x take away 1x, okay, is 7x. So we've got 2x terms, so we can group those together, and that would be 7x. And we've got this constant on the end, minus 1. So you just put that as minus 1. Okay? So you group together the x terms, and then you group together any more constants, but there's only just this one constant there. So there you go, 7x minus 1. Now with this one, I chose this one purely because I wanted it to start with a negative term and I wanted to mix up x's with x squared terms. So we've got 4 terms here. We've got a couple of x terms. We've got minus 3x minus this 3x. So minus 3x, they can be grouped together, and that's going to be identical to minus 6x. And then we've got x squared terms, minus 4x squared plus 4x squared. And that gives 0, no x squareds. You could write down here, if you like, I suppose, plus no x squareds, or even minus no x squareds. But what's the point? That's just 0, so we'll just leave that, okay? And we've just got minus 6x. Now in number 6 here, okay, we've got 1, 2, 3, 4, 5 terms, and we've got an a squared b term here. Have we got any more a squared b terms? Yes, we have. We've got one here, okay? 2 of them, 2a squared b. So we can group these together. 1a squared b plus 2a squared b, well, that's going to be identical to 3a squared b. Let's put some ticks over the top because I want to try and remember which ones we've used. Looking at this one, this term here, we've got an ab squared term, minus 3 of them. And we've actually got minus an ab squared term here. I've written it back to front, but it's still an ab squared term. Minus 1 of them. So we've got minus 3ab squared minus another 1ab squared. So that's minus 4ab squared. Okay, so we just put ticks over those. And we've got one extra term left over. There are no other a terms in the expression, so it's just simply plus a. Okay, so hopefully you'll be able to simplify expressions now that contain lots of terms. Okay, just group together like terms. Okay, well that brings us now to the end of this tutorial.